DMAIC is a structured, data-driven five-phase methodology used to improve, optimize, and stabilize existing business processes. It is the core framework used within Lean Six Sigma to reduce defects, eliminate waste, and minimize variation. Lean Six Sigma is a data-driven, team-focused methodology that improves performance by combining Lean's eliminating waste and non-value-added steps, with Six Sigma's reducing process variation and defects. It optimizes efficiency, speed, and quality, aimed at increasing customer satisfaction and reducing operational costs. Lean Six Sigma is used across manufacturing, healthcare, and service industries to eliminate inefficiencies and improve process stability. The core principles are to focus on customer value, identify waste, defects, overproduction, and waiting, to improve process flow, and reduce variation using statistical tools. The benefits are increased profitability, faster cycle times, enhanced quality, and improved, consistent operational performance. Lean Six Sigma uses the DMAIC methodology as the backbone of the system to improve existing processes. DMAIC stands for Define, Measure, Analyze, Improve, and Control. Next, the stages will be explained in detail. The Define phase is the first stage of the DMAIC methodology, focused on identifying the project goal, scope, and, most importantly, the problem to be solved. It involves creating a project charter, identifying stakeholders, and mapping processes to align team objectives, typically consuming 10 to 15% of the project timeline. Key aspects of the Define phase include goal definition, clearly articulating the problem, objectives, and, crucially, the desired improvements to the process. Project charter, developing a core document that outlines the business case, problem statement, scope, and team members. Customer focus, identifying internal and external customers and understanding their requirements. This is commonly referred to as the voice of the customer or VOC, or critical to customer or CTC. Process mapping, utilizing tools like suppliers, inputs, process, outputs, and customers, or SIPOC, to understand the high-level process boundaries. And scope definition, setting boundaries to prevent scope creep and ensure the project remains manageable. The phase concludes with a finalized project charter that acts as an agreement between the team and leadership on the project's focus and scope. The measure phase in Lean Six Sigma is the second step, focused on gathering, validating, and establishing a baseline for current process performance. It involves collecting data on key metrics, verifying measurement systems, and mapping processes through SIPOC and value stream maps to understand the as-is state. Key activities of the measure phase include: establish a baseline, quantify the current performance of the process to compare with future improvements, map the process, utilize tools like SIPOC or value stream mapping to visualize the current workflow, develop a data collection plan. Define what data to collect, who will collect it, and where to pull it from, to ensure consistency. Validate the measurement system. Ensure the data is accurate, reliable, and consistent. And calculate process capability. Determine how well the process currently meets customer requirements. The deliverables of this phase are: a validated measurement system, a documented as-is process map, a data collection plan and raw data, a baseline process capability score. The goal of this phase is not to identify causes, but to deeply understand the current situation and establish reliable data for the subsequent analyze phase. The analyze phase is the third stage of the Lean Six Sigma DMAIC methodology. Following the measure phase, which collected data, the analyze phase focuses on examining this data to identify the root causes of process inefficiencies, defects, or variations. The primary goal is to move beyond symptoms and identify the vital few root causes that have the highest impact on the project's critical to quality or CTQ factors. The analysis phase key objectives include: identify root causes. Determine why the problem is occurring, rather than just knowing how it performs. Processes have critical inputs to create outputs, and these must be identified to improve the system. Analyze process data. Use statistical tools and process mapping to identify patterns, trends, anomalies, and bottlenecks. Verify hypotheses. Formulate theories about why problems occur and use statistical methods to prove or disprove them. Test theories about potential causes using data, not just intuition. And prioritize causes. Narrow down the list of potential causes to the most critical ones. Quantify the difference between current process performance and the desired target. The key activities of the analyze phase are: process analysis. Examining the as-is process map and value stream map to identify waste such as non-value-added steps, waiting time, and bottlenecks. As-is process mapping is the documentation of a business's current workflows, capturing exactly how processes operate in reality rather than how they should. Data analysis and statistics. Using tools to analyze data trends, such as histogram deep dives, scatter plots, and regression analysis. Data analytics focuses on extracting actionable insights for immediate business decisions using tools, while statistics provides the mathematical foundation and rigorous validation required to ensure findings are reliable and not just random chance. A root cause analysis, or RCA, is a structured, systematic process for identifying the fundamental, underlying causes of problems or failures, rather than just treating immediate symptoms. Some root cause analysis methods include fishbone or Ishikawa diagram, brainstorming potential causes across categories like people, machine, material, method, and environment. 5 whys, repeatedly asking why to drill down to the root cause. Pareto analysis, applying the 80-20 rule to focus on the top 20% of causes responsible for 80% of the problems. Hypothesis testing, using statistical tests to confirm whether a suspected factor truly influences the output. And failure mode and effects analysis, or FMEA. This is used to proactively identify potential failure points in the process. Common pitfalls of this phase are: assuming root causes, jumping to conclusions without supporting data, focusing on symptoms, addressing the visible problem rather than the underlying cause, and poor data analysis, misinterpreting data or overlooking key patterns. The key deliverables are: verified root causes, a validated list of the true causes of the problem, detailed process maps, updated maps highlighting bottlenecks and inefficiencies, updated project charter, revised based on new insights, and data analysis results, charts, graphs, and statistical tests supporting the findings. The analyze phase is considered the heart and soul of the DMAIC process, as it directly leads to the development of solutions in the subsequent improve phase. The improve phase in Lean Six Sigma focuses on developing, testing, and implementing solutions to address root causes of defects, typically spanning 8 to 10 weeks. It involves brainstorming, piloting, and refining solutions, often utilizing tools like failure mode and effects analysis to reduce risk, while ensuring employee involvement to drive sustainable, efficient process changes. Key activities in the improve phase include: generate and prioritize solutions. Brainstorm potential solutions and use selection criteria to determine the most effective, practical, and cost-efficient options. Develop implementation plan. Create a detailed plan covering logistics, required resources, budget, and timelines. This will often require briefing top management to get their support. Pilot testing. Test the proposed improvements on a small scale to validate effectiveness, minimize risk, and allow for adjustments before full-scale rollout. Validate improvements. Use data to confirm that the changes have resulted in measurable improvement, such as reduced defects, lowered costs, and improved efficiency. And process mapping and standardization. Document new, improved processes to ensure they are adopted and maintained. Once improvements are validated during this phase, the project moves to the control phase to establish long-term monitoring, standardization, and training, ensuring the gains are maintained. The Lean Six Sigma control phase ensures process improvements are sustained, preventing regression to old methods. It bridges the gap between project completion and permanent operational integration. Instituting controls can be the difference between temporary and long-term improvements. The key components and tools of this phase include Control Plan, a document outlining the necessary monitoring actions, key performance indicators, and frequency of checks for the new process. Standard Operating Procedures or SOPs, updated, written procedures that institutionalize the improvements. Without written standardized processes, it will become easier to slip back into old ways, and the gains will be lost. Statistical Process Control, the use of control charts to track process performance over time and identify variations. SPCs are necessary to ensure the processes stay within the new parameters. Mistake proofing, also referred to as POCA-YOK-A, implementing mechanisms to prevent errors from occurring. It uses a twofold approach, either preventing an error from occurring or providing an immediate warning when an error occurs. And training and documentation, ensuring that all personnel involved are trained on the new standards and procedures. Personnel must be monitored to ensure they understand and adhere to the guidelines. The essential activities of the control phase include transitioning ownership, handing over the improved process to the operational team. This transition must be systematic and include training and support. Change management, a structured approach to transitioning individuals, teams, and organizations from a current state to a desired future state, ensuring smooth implementation of changes. It involves preparing, supporting, and equipping people to adopt new processes, technologies, or structures, minimizing resistance and disruption to maximize return on investment and success. Response plan, establishing a protocol for when the process moves out of control, ensuring quick corrections. This requires monitoring systems and a plan of action to get the process back under control. And the final tollgate review, a formal sign-off by leadership to confirm that all improvements are in place and sustained. Without proper control, roughly 70% of process improvements may fail to last beyond a year. Thank you for watching this video. If you want to learn more about organizational improvement topics like Gemba, 8 Wastes, 5S, Total Quality Management and many others, click the subscribe button to access the FSTG library.